Very pleased to have Alan Manning presenting the next paper on monopsony and migration. So the house rules will remain the same as before. Feel free to unmute yourself and ask a question, interrupting the speaker, and you have 45 minutes, Alan.
Thank you. So this is joint paper with Michael Amior. Okay, so what is it about? It's basically about, it's a paper in the tradition of the structural approach to estimating the wage effects of migration, which a number of other papers have used that approach. The standard approach of those kind of models has been to use a sort of nested CES, constant returns to scale production function, and assume perfect competition. Now, this approach has sort of well-known advantage that it allows spillovers across labour markets, and it takes account of the fact, which is undoubtedly true, that immigrants are very heterogeneous. So the mix of immigration may be as important as the level of immigration. But it also has the well-known disadvantage that it requires making some assumptions about the production structure, in particular the patterns of substitutability between different types of natives and migrants. And the results are only good, good if you get those assumptions right. And so there are problem issues around occupational downgrading of migrants and so on. But this paper is on a different issue related to these models. So it's got partly a theoretical part, which is a sort of a lead into the empirical part. And the basic point it makes here is that if you impose a constant returns to scale production function and perfect competition, that imposes a limit on the possible empirical results you can find. In particular, we show that any such model must have the prediction that an increase in immigration holding the skill mix constant must benefit natives on average. So must raise their marginal product on average, and with perfect competition, their wage as well. And so the data, the estimates, can give no other answer. And that's slightly concerning because obviously it limits the range of conclusions that the empirical analysis can give you. But we show that the model does have testable over-identifying restrictions. And in order to sort of test those restrictions, one needs to generalize the model. The way in which we do that is to assume the labour market is monopsonistic. I can't think where I got that idea from. And that possibly the extent of monopsony power that employers have depends on the share of migrants in the particular labour market. And then we develop and implement an empirical approach of that kind of model. So I'm going to just start with the theoretical results and really the simplest case, which I'm sure I'll go very quickly because I think almost everyone probably knows this. So if we have a constant returns to scale production function with two types of labour, call them native and migrant, N and M, in inelastic supply, and we have perfectly competitive factor markets. Now the constant returns to scale production function you should think of as behind the scenes. There are other inputs into production, but they, like capital, but other possible inputs as well, but they're in perfectly elastic supply. So this is a sort of a long run model when things like capital and non-labor inputs can adjust perfectly. So we can just work with constant returns to scale in types of labor alone. And and this is a sort of a result that Borjas, I think, first derived in his sort of JEP paper in '95. And he's what he called the immigration surplus result, is that if you, in this production function structure, you have an increase in migration, an increase in M, that must raise the average margin, the marginal product of natives. And the reason is that when you've got constant returns to scale and only two inputs, the inputs have got to be complements to each other. So raising the number of migrants must raise the marginal product of natives. Now you might think, well, that's actually rather a special conclusion. It's only got two inputs, natives and migrants are homogeneous, but actually it's far more general, and the sort of a flavor of that can result is far more general. And so I'll kind of just illustrate one version of that, which is that if we've got any number of types of labor, so here going up from type 1 up to type J, that for each type of labor there might be some natives with of that type, there might be some migrants of that type, but it's quite possible actually in this setup that each type is either uniquely native or uniquely migrant. They don't have to be overlapping in their skill mix at all. And suppose we change the stock of migrants in this framework, holding the skill composition of migrants fixed, so the fraction of migrants who are each type. So simple way of writing that is to say, well, let's say that the share of migrants with skill J is mu J, the share of natives with skill J is eta J. So we can write the production function as in the following way. So instead of writing n1 plus m1, we write eta1 n plus mu1 m and so on up. And you can think, because we're going to hold the skill mixes constant, you can think of the etas and the mus as just parameters in the production function. And so that this production function I've written up at the top of that slide can just be thought of as a synthetic production function of just two inputs, natives and migrants. And that's sort of what sometimes I think called Hicks aggregation. It's sort of long way back in microeconomics. And the important point about this synthetic production function is that it just behaves like just any other production function. So it's got constant returns to scale if the underlying production function has. And in particular, the marginal products are equal to the marginal products of natives on average is equal to the marginal product of the synthetic production function. And so what that means is that we've reduced a production function with an arbitrary number of types of labor to one in which there are only two types of labor. And then we just showed a minute ago that if you've only got two types of labor, they must be complements. And so a rise in the number of one type must raise the average marginal product of the other type. And so that means that any production function that has constant returns to scale is going to, and you're going to assume perfect competition, so wages are equal to marginal products, is going to have this feature that a constant skill mix increase in migration must benefit natives on average. And all the models in the structural approach actually are far more restrictive than that. They assume a particular CES production function, but that's a sort of special case of this general thing. And actually you can go even further than that. I'm not going to go through this, but in the paper, basically what we do is we do a model in which there are many goods, so there are relative price effects as well. So in this case, what we're showing that for an arbitrary number of labor types, for an arbitrary number of goods, which might be final consumption goods, intermediate goods, or capital goods, you still get this Borjas immigration surplus result that an increase in migration, holding the skill mix of that migrant flow constant, must raise the average utility of the natives. And you can also add in changes in the skill mix as well in this. So if you say, well, let's keep the level of migration the same, but let's alter the skill mix of migrants in a way which makes migrants and natives, if we make migrants and natives more similar, I should perhaps have put this the other way, then you can show that that must reduce the average marginal product of natives. So again, this is an idea in the Borjas paper, but is actually far more general than the model in which he expressed it, which is that if you make migrants more different from natives, that's to the benefit of natives. So the bottom line here is that these assumptions about the production function constrain the possible conclusions you can come to about the impacts of migration on the wages of natives. Now, there are limitations to what those results don't say is they don't say that when you have a constant skill mix rise in immigration, the wages of all natives must rise. So it can be that there are big effects on inequality. It doesn't say that immigration always raises the average marginal product of natives, because it assumes something about the skill mix, namely that it's constant. And it doesn't say that the effect is big in any way. But as I say, it does say that these models constrain in a way that we might think is a bit problematic the possible conclusions that you can draw about the wage impacts of immigration. So if we want to, what we want to do is, if we're a bit worried about that, we need a more general framework. And basically there are two underpinning assumptions here, which are the one of constant returns to scale and perfect competition. So if we're going to get a different possible conclusion, we're going to have to relax one or both of those assumptions. Now, relaxing constant returns to scale, I think, is unattractive, particularly in the long run, because, well, we think that if we look at, you know, countries with higher levels of population, that's not generally associated with lower real wages. So that suggests that constant returns to scale is a pretty attractive assumption, certainly over a longish time horizon. So we're going to go in the other direction. We're going to keep constant returns to scale, but we're going to relax the assumption of perfect competition. And in particular, we're going to assume monopsony. So what that does is the following, is that it means that wages are now going to be a markdown on the marginal product of labour. And so there are going to be, and so we're going to represent that in this following the equation in there. So the log of wages is the log of the marginal product minus the log of phi. So phi is this markdown, and we're going to allow potentially the markdown to depend upon the share of migrants in your labour market. Now, I'm not going to go through it in today's presentation, but the paper has a sort of micro foundation for why that might be, where you might get that equation from. But for the presentation, you can ask me questions about it, but I'm just going to...
May I ask you a question?
Yeah. Sure.
So about, just asking about this departure now that you're making from the Borjas setting, would be another option, another departure would be that we think about not a functional form of a production function, but we think about this kind of task assignments, that when the immigrants comes in, you know, the natives moves to different type of tasks, and that creates wage effects for immigrants.
So that would be, if we go back to the production function up here, so what I've assumed here is if we go back to a model in which there are an arbitrary number of types of labor, which might be tasks is one way in which you might differentiate labor. In this setting here, I've assumed that natives are of a particular type, so there's an inelastic supply. So what you're talking about there is the possibility that you know, migrants come in and they're good at one sort of task, but then natives can substitute more easily to some other types. So in that possibility, the results that we're deriving here, you should think of as results about the way in which the average demand curve shifts for natives. So this is saying, so this result should be interpreted then as that the average demand curve for natives is going to shift out when you get migration with these other assumptions. Now, whether that shows up in changes in wages or changes in employment depends a bit on the elasticity of supply to the market as a whole, to different, you know, to different jobs. So I think it would be the case if you generalized it, you would get the conclusion, you would continue to get the conclusion that on average, this has to be to the advantage of the natives, but it's not quite, it doesn't exactly fit in the way we've done things. And I should say actually that when we come to the empirical estimates, we're actually, we're sort of in using actual employment levels instrumented. So in some sense, any adjustment of natives is sort of a bit incorporated in that, although not modeled very explicitly. So we're going to vary, instead of simply assuming perfect competition where wages equal marginal products, we have wages potentially a markdown on marginal products, and we're going to allow the markdown potentially to depend on the migrant share. And in particular, we're going to, in the empirical application, just have the functional form written down there, that the log of the markdown is an intercept and a slope. So, and the slope being the slope relative to the log migrant to native ratio, which is essentially a function of the migrant share in the labour market. And we allow potentially these functions to be different for natives and migrants. So it might be possible that it's only the migrants who suffer from the exercise of monopsony power, and it doesn't affect the natives at all. That will come out in the empirical analysis. So why might assuming that you know, the markdown possibly depends on the migrant share, might that be reasonable? The first reason is that in the standard framework, where wages are equal to marginal products, individual employers shouldn't really care less about whether they have access to migrants or not, whether they're able to hire migrants or not. But over the last few years, I've spent quite a lot of time in rooms with employers talking to me about migrants, and you don't have to be in a room with them for very long to realize that actually they care quite a lot about having access to migrants. And that suggests that, well, one possible explanation is the marginal product of labour is above the wage. And indeed, employers seem to be prepared to pay money on visas and things like that in order to hire migrants, which they don't have to pay for natives. Again, that's suggestive that they're getting the marginal product they're getting from them afterwards is above the wage. It may be that now in the model that we have, migrants in some sense affect monopsony power for natives if in some sense the labour market for migrants, sort of employers have more monopsony power over migrants than they do over natives. And there are a number of reasons for why that might be the case. I think it might be that the migrants just don't know what's going on in the labour market so much. They might be that they have lower reservation wages. So I'm trying to send my own kids out of the room here, which is why I'm waving in a strange way. It might be that indeed the immigration system itself imposes restrictions on the labour mobility of migrants. So in some sense gives employers monopsony power. And there are some other studies providing some suggestive evidence that actually employers do have more market power over migrants than natives. But ultimately what we do here, you know, we don't rely on those studies. You know, we aim to estimate the impact directly. So what we're going to do is...
Alan, sorry, one question. So
yeah.
is it really the migrants who are already in the country that matter, or the migrants, the potential migrants that matter, or is it just that one's a proxy for another that you can really capture?
I mean, that's a good question. We're only using the ones that are in the country. I mean, we do in one of the robustness checks look for a different effect of new migrants versus, you know, older sort of migrants who've been in the country longer. We don't find very much evidence for that. But I think, you know, that doesn't quite address the question of migrants who might be in the country, you know, who potentially could be, but aren't really. I don't really know quite how we would do that. So basically, we're going to just assume a traditional multi-level sort of CES production function. Basically, all the action is at the lowest level part of that production function, which in our application is going to be an education experience cell. So everything I'm going to show you is really just down at that sort of the lowest level. So we're going to write this, what we call the cell aggregator, sometimes called the Armington aggregator, at that level as being a function of natives and migrants. So at the lowest level, we have a CES production function. We allow, even at the lowest level, natives and migrants to be possibly not imperfect substitutes. So sigma Z might be different from 1. And we also allow them possibly to be different in their productivity, even at this low level. So in practice, these are all going to have education experience times subscripts on them. But for the purposes of exposition, I'm just going to drop all those subscripts. Now, with that sort of cell aggregator, what you can do is to derive a relative wage equation, the wage of natives, migrants relative to natives in the particular cell. And if you do that, you get an equation that looks like this. So the log relative wages depends partly on an intercept, and the intercept comprises both the differential productivity effect and the difference in the intercept on the monopsony effect. So for example, if employers have simply more monopsony power over migrants, phi 0 would be lower for migrants. And as a result, you'd see migrants within a cell having lower wages than natives, even if they have the same level of productivity. And then we have a slope coefficient, which is on the relative supplies within the cell. And that's going to be a function of the elasticity of substitution between natives and migrants in that particular cell, but also the difference in this slope coefficient of the impacts of migrant share on the monopsony power of employers. And so then you can see that if you estimate this kind of equation, and the structural approach has often estimated that type of equation, the intercept in that type of equation is going to estimate the log of alpha z minus the differences in phi zeros, and the slope is going to identify 1 minus sigma z plus the change in phi 1s. And I think what you can see immediately is that, well, that relative wage equation hasn't got enough information for you to identify what's going on here. So the standard approach, if you assume perfect competition, is to simply assume that there's no markdown. So that means the delta phi's must be 0. Both delta phi 0 and delta phi 1 must be 0. In that case, you obviously can, under those assumptions, you can identify alpha z and sigma z from the relative wage equation. And that's what the literature does. So the model is in some sense going to be under-identified, and we're not going to present a model that's completely identified at all. But the point that we make is that although you can't identify all the parameters of the model, you can test some interesting joint hypotheses, and you can sort of identify parameters as well. And in particular, I want to sort of distinguish between two hypotheses. The first one is what we call equal markdowns. So this is delta phi 0 is equal to delta phi 1 equals 0. So this would be, if there is monopsony power, it's the same for experienced, the same level by natives and migrants. And then the second hypothesis is independent markdowns. So namely for natives, namely that the markdown for any markdown for natives doesn't depend on the migrant share within the cell. And what I'm going to show is that you can test those joint hypotheses. And why is that attractive? Well, that's attractive because perfect competition is a special case of those two hypotheses, in which the case the markdowns are 0, so they must be equal to 0, and the markdown can't vary the migrant share because it's always 0. So we are going to be able to develop a test of perfect competition, and we're going to be able to implement that.
Alan, sorry,
yeah.
Question. But so is there like an assumption that migrants and natives with the same level of education and age are equally productive, right? So that you're going to find...
Not necessarily. So that's the alpha z parameter, essentially.
Right. And
so we're not going to assume that they're equally productive.
Okay. So how you're going to tell us how you're going to?
If I can get to it a little bit later.
Sure. Yeah.
Can I also ask one small question to understand the setting? So in this setting, or do you think there's a possibility in this setting is not possible? I think you correct me if I'm wrong. Do you think there's a possibility that amount of immigrants will change the monopsony power of firms?
Well, that's embodied in this equation down the bottom of this slide. So if you change the number of immigrants,
got it.
Yeah, great. That alters the markdown. I mean, we do it as a function of, it's the relative supply, so it's not the absolute number, but I think that's a sensible, scaling assumption. Yeah. So that's exactly all these phi 1s about how changes in the migrant share within the cell affect employer monopsony. So how do we do our test of perfect competition, or more specifically, the joint test of these two hypotheses? We take a two-step strategy. So what we do is, first of all, we impose equal markdowns. So that the delta phi 0, delta phi 1 is equal to 0. That means that the relative wage equation identifies alpha z and sigma z. Once we've got those estimates of alpha z and sigma z, we use them to construct the cell aggregator at the lowest level, this Z function. And then we can use that cell aggregator in the following equation. So you can derive an equation for the absolute, what we call the absolute wage equation. So this is for natives. So this is the log of native wages. And basically what you can see is that log of native wages are going to be a function of the level of employment, sigma Z, but we've estimated that under our null hypothesis. The Armington aggregator, we can estimate that under our null hypothesis. And in particular, there's going to be an impact of the skill mix on native wages according to this, whether the monopsony power depends upon the migrant mix in the cell. So what we can do if we estimate this model, we're going to be able to get an estimate of phi 1n. And so particular, we're going to be able to estimate whether phi 1n is equal to 0 or not. So one way of thinking about this regression is we're regressing native wages on the cell size, the size of the cell, which might be influenced by migration, just how many workers like you there are in the labor market. And that's represented by the impact on the cell aggregator, and then also on the cell mix. And we're thinking of the coefficient on the cell mix as identifying the market power effect. And that's sort of, if you look at the literature on immigration, sometimes they estimate the impact of migration through a cell mix effect and through a cell size effect. And this sort of rationalizes there might be two separate channels, the cell size and the cell mix effect, and we're sort of giving a market power interpretation to the cell mix effect. So in terms of empirical application, basically what we do is we just take the classic studies that I guess first started with Borjas and Ottaviano Perry, and a number of other papers as well, in which we use US censuses. We sort of expand it a bit to have the most recent data. For each year we have, 32 labour market cells, 4 education groups, 8 experience groups. We're just looking at wages of full-time men. Again, a lot of this is we're just sort of trying to vary as little as possible from what other people have done. There are 2 issues that we do a little bit different. So we do residualize the wages. We show estimates both residualizing and not, and we use IV and OLS as well. So residualizing wages, that's partly because a paper by Ruist suggests that actually some of the estimates in the literature may be driven by the changing migrant composition. So particularly even within an education experience cell, as the share of migrants has risen over time, they are from countries which on average tend to have lower wages. So that can sort of, that causes a problem in your estimated effect. So you can sort of residualize by origin country effects and demographics. So we sort of do a bit of that. And then we instrument for employment, both native employment, which is basically the population of people with a particular age, a particular education level, but for migrants as well. And we take a model that other people have used to predict migrant flows into the UK, which is around sort of demographic changes in countries of origin. So again, we just sort of borrowed that from somewhere else, but that allows us to, so all our estimates are going to be on employment levels, but they're always going to be, but some of the, when we instrument, we're essentially instrumenting in this kind of way. So these are the sort of estimates that we sort of get. So this is from the relative wage equation. So we're regressing relative wages of migrants to natives within a cell on the log relative supply within that cell. So the first column is pretty close to Ottaviano and Perry. So you do get a significant negative coefficient on the relative supply, but it's pretty small, suggesting that within the cell, migrants and natives are pretty close substitutes. You also get a negative effect of on the intercept, which basically means that within the cell, migrants are less, the way that would be interpreted within the model, migrants are less productive, but more generally they're being paid lower wages within the cell than the natives. Now, as we sort of composition adjust and introduce instrumental variables, that changes a little bit. In particular, we tend to get the results that you get, it looks more like perfect substitutes when you in the basic estimates, but we also experiment with including different fixed effects that you can include in these equations. But the basic line, you get sort of similar kind of equations here. You get a sort of perhaps a small evidence of some lack of some degree of imperfect substitution, but not that much, and some evidence that migrants get lower wages within the cell than natives, which, if you have perfect competition, is all interpreted as a productivity effect. So what we're doing is we're taking these estimates and then we're using them to compute the sort of cell aggregator. We're imposing the assumption that there are equal markdowns, if there are markdowns, so that then we can use these estimates to get an estimate of alpha Z and sigma Z. We're then computing the aggregator, and then we're going to the next second step of our procedure, which is to estimate a native wage equation. And basically, again, what we're doing here is, these are the equations. So you get an equation which is, you get a coefficient on the size of the cell, which is measured by the cell aggregator here. And because you're close to perfect substitution, this is actually pretty close to being just the sum of the number of natives and migrants in that particular cell. You're getting an effect here. So the coefficient on this variable is telling you about actually the elasticity of substitution at the next level up in the CES production function. We're not particularly interested in that here. What we're interested in here is the coefficient on the log of the relative supply, which is going to be our test. If this is 0, that means we're accepting the null hypothesis of no dependence of native markdowns on the migrant share, conditional on equal markdowns. But most of the specifications, in particular the preferred specifications, are that it's significantly different from 0. And so the way you should interpret that is that this would imply that a higher share of migrants within the cell leads to bigger markdowns for the natives. And so that would imply that more migrants in your particular labor market is giving employers more market power, which affects not just you, not just them, but you as well as a native as well. Now we also experiment here with a bit with the functional form. We include the relative supply here because that fits well with the sort of relative wage equation. But I think there's some arguments to think that if there is a markdown effect, it's actually the migrant share rather than the log of the relative supply that's important. And if you do that, then you sort of get I think actually that does work better, a bit better empirically, but you get a similar qualitative conclusion. So the bottom line is that from this equation, what we do is we reject the joint hypothesis of equal and independent markdowns. And consequently, what that means is that we reject perfect competition. And conditional on equal markdowns. So what we've done so far is really shown that if markdowns are equal for natives and migrants, then more migration reduces wages for natives through an increased markdown effect. And we can reject perfect competition along the way. But one proviso to those results is that these are the estimates that are based on the assumption that markdowns are equal. So that's where we got our alpha Z from, our sigma Z from. But perhaps they're not equal. And in that case, is this, the natural question is, can we draw the same conclusion? So the next thing we want to do is to relax the assumption of equal markdowns. Now, in that case, what we don't have is point identification of parameters. So you cannot fully identify the models. There simply isn't enough information in the very simple variations on wages and wages of natives and migrants, how that varies with the numbers of natives and migrants. There just simply isn't enough information in that to identify all of the parameters. But what we will show is that we do have sort of set identification here. And what I mean by that is, suppose that we fix the values of alpha z and sigma z. So we fix the production function parameters at some value in the lowest level of the CES production function at some values. Then our relative wage equation gives us estimates of the difference in the markdowns for natives and migrants. So delta phi 0 and delta phi 1. Now you could do this the other way around. You could fix the differences in the markdowns, which is what we did before. We fixed them at 0, and then use the relative wage equation to fix alpha z and sigma z. That would be the same thing, just looked at from a slightly different direction. So basically, but if you fix one of these pairs, you're going to be able to estimate the other one. Once you've done that, you can construct the Armington estimator, and then you can estimate the absolute wage equation, and then that gives you an estimate of phi 1n. And because you've also got an estimate of delta phi 0 and delta phi 1, that also gives you an estimate of phi 0n, how migrants are affected, how the markdown for migrants is affected by the migrant share. But there is something that you fundamentally can't identify. So for example, you cannot identify the level of the markdown for both groups in this model. And the reason for that is that the level of the markdown just affects the level of wages, but so does the just general level of productivity. And there just isn't enough information in wages to be able to identify that. But you can point identify a set of interesting parameters for any combination of the production function parameters. And so our strategy then is to just start varying those production function parameters and just see how our conclusions vary with those assumptions. And that's what this estimate does, what this picture does. So basically what it does, it shows you three possible values of sigma. So sigma equals 0, which, up to sort of sigma equals 1. And then different values of the relative productivity of migrants to natives within the cell. And then it shows you on the vertical axis the values of phi 1n. So a positive number here means that an increased migrant share within your cell is depressing your wages. And what basically you can see is that whatever the parameter values we assume about the production function, you get the estimate that actually an increase in the migrants within your cell is increasing the markdown for native workers. Now, the magnitude of that effect does depend upon the production parameters. So this effect would be pretty small if you wanted to assume that sigma z was equal to 1. But if you go back to this equation, we're actually quite a long way from in the empirical data. If you assume sigma z is equal to 1, that's quite a long way from where. Sorry, so sigma z we're pretty close. So sigma z we're pretty close to 1 most of the time, but you can get even bigger effects if you go away from that. I didn't explain that very well at all. I always get confused by which sigma is going in which direction. I've never been able to get that right. But the bottom line is that although the magnitude of the impact varies, the direction of it is always the same, whatever assumptions you come to. Now, how large are they? Well, they're quite large. So if you sort of take the estimated parameter values and you sort of churn through what the effect of changes in migration on average marginal products is, those are really small numbers. But these markdown effects are not that small. So it suggests that actually the markdown effect is the dominant effect if you're interested in looking at the impact of migration on wages. It dominates the marginal productivity effect. We do a whole series of sort of robustness checks and extensions. I kind of won't run through those, but we get more or less the same conclusion. So basically the conclusion is that if you take this kind of structural approach, which I think does have its uses, but you impose the combination of constant returns and perfect competition, you're basically limiting the possible conclusions that you can draw from the data in a way that's not really perhaps very comfortable with. So what we do here is replace perfect competition with monopsony. We do find some evidence that there's a negative impact of migrant share on native wages through higher markdowns. But I think the point I would like to emphasize is, although I think the literature is a bit inclined to think in terms of what is the impact of immigration on, say, wages, I don't think that's a very well posed question, because it depends on the skill mix of migrants. That's one reason. But it also depends upon the labour market institutions in which immigration is in the country. So this is sort of saying that in the US labour market, which doesn't really perhaps have many institutions that offset the monopsony power of of employers, that it may be the case that migration is enabling giving employers greater monopsony power. But it's possible that the impact of immigration will be different with a different set of institutions which sought to limit that monopsony power. So I'll just stop there. I think there's a few minutes left.
Yeah, you have about 3.5 minutes if there's more questions.
Can I ask? I have two questions. I've asked the first one, and if there's no other question, I'll ask the second one. So the first question I have is that, do you think there's a place here? Because my feeling is that your exercise can be done at the industry level or industry occupation level. Because one would think that, you know, an immigrant who comes and open a shop or become a taxi driver, that does not have the same monopsony power. Yeah, this mechanism that we talked about will go through much harder than if you think about the factory worker.
Yes, so I think first of all, you could take this approach to, segmenting the labour market in any way that you want. So you could, this is done on education experience, you know, partly because the literature does that, but you could do it industry, occupation, geographical, if you thought that was important, and so on. I think when you go down to occupation, you've got to worry a little bit more about the issues that you talked about earlier, that people can move out of one occupation and into another occupation. Whereas here, you know, once you're 30 years old, you're stuck in an education cell. You can't really move. So you have to pay much more attention probably to the elasticity on the supply side. And actually, one of the ways in which I'm thinking about trying to extend it is in that direction. But I think the general approach you could take, you know, cutting up the labour market in whatever way you want.
You can go on, Arash, if you had another question.
Sorry, so my second question was about the fact that I felt that here, what happens is the immigrants are pushing down the wage of the workers at the end in the benefit of the capital. Could it be that the one who's benefiting actually is the very skilled workers, in the sense that those entrepreneurs? So in a way, how you think about the monopsony power? Who has the monopsony power? Is it the people that you talk to it? Those are entrepreneurs, right? Those guys who want these unskilled immigrants here. Yeah, those are the guys who are benefiting from it. So, and those are not in the model in a way.
Yeah. So the question you're asking, one way to put it is, if employers have monopsony power, where are those rents going? You know, and in this setup here, they're sort of going into profits really, because there's nothing else. You know, but we're not really modeling firm entry. We're not modeling, you know, because it's a one good model. There are no relative price effects. So it certainly might be the case in this setup that low-skilled migrants raise the marginal, you know, they don't affect the monopsony power of higher skilled natives because they're not competing in the same labour market for the same jobs, and they raise the marginal product of high-skilled natives. So it's quite possible in this setup that, you know, lower skill migration is to the benefit of high skilled natives. But what it is saying is that if you get migrants into your cell, into your labour market, that, you know, depresses your wages. Again, you could look for heterogeneity in that effect. We do that a little bit, but we probably don't have that very much power. So these phi 1 parameters might be different according to education cells, for example. You know, again, you could take the framework in that way. I think we run out of power quite quickly, so we don't really do that. But again, that would be an interesting question.
I mean, another dimension of heterogeneity in that phi is, I mean, going back to Guy's question, how old people have been in the countries. Because in the country, I mean, the longer they've been there, you may think that they're more assimilated, they have better access to welfare. So the sort of average cohort of migrants may have an impact on the markdown. I mean, on the other hand, you may think that very recent migrants are much more mobile than established migrants, so it can go the other way as well.
Yeah, yeah. So, I mean, I think that's a sensible, I think, to think of. We did try and explore that a little bit to say whether it's new or old migrants. We didn't find very much in there, but basically, I think there are some power issues probably in here. So, I mean, again, that would be if you had more data, better data. I think that'd be interesting. But as you say, I think there are arguments that go in both directions. So, and it may also be the case that new migrants are actually in segments of the labour market where there are very few natives at all. So in some sense, the fact that they're not having any competitiveness externality on natives because there just aren't that many.
There's one last question. I've seen a raised hand by Anna Raute.
Ah, yes. Hi, Alan.
Hi.
So it's a bit more of a sort of political question now regarding Brexit. So you also mentioned that employers are really willing to sponsor a visa. And so there's a sort of question, so now if now European workers potentially, there's an increase in migrants who are working on visas and don't have full kind of access to the labor market, I guess employers' monopsony power over those migrants will increase. And I'm just wondering how this will interact as well with natives for wages, and what we also think that will increase the monopsony power also. So the increase with the migrant share will also increase in terms of monopsony power then?
Yeah. So I think that's a really good question. It's actually something I have had to give some thought to. I think there are two effects. So first of all, you're right that if you have a work permit that restricts, makes labour mobility harder, and Europeans will have to have that will increase monopsony power. But on the other hand, there are normally conditions on those work permits. And one of those conditions is minimum salaries. And so there's some evidence that, because you see bunching of work permits at the minimum salaries allowed, there's some evidence that employers are going to basically use that to try and so then in that sense, moving to work permits with higher minimum wages for migrants is basically reduces their monopsony power. And I think there's a bit of a trade-off in those. I mean, when I was on this committee making recommendations, we tried to say we thought salary thresholds are really important, but we also want to take measures to make it easier for migrants to move employers once they're in the country. But I think that it is a difficult question.
Okay, thank you very much.